about it.
I'm sorry.
It'll be fine, it'll be fine.
I didn't know we were having a pro generics discussion.
I'm not bashing generics today.
Okay. Always time later.
It'll be a short talk, huh?
I've never heard of a language where generics didn't create dependency help.
Yeah, it's gonna be fun. I'm excited. It's gonna be a contentious topic, so.
I believe it's possible that the Go offers different things to prevent dependency help from happening.
If used properly, they'll be okay. Used properly behind the scenes, sort of like channels.
Oh, like Microsoft said about cookies.
Yeah, you know. Yeah, exactly.
Nobody would want to use them the wrong way.
Nobody is ever gonna use the feature the wrong way.
Okay, cool. I'm sold.
Yeah, all right. Thanks everybody for coming. We're gonna get started. User group meeting for April 5th. We'll go just really briefly over some of the basic stuff and then dive into it. There's the Board Utah Slack. If you're not in there, that's a great place to be. We do all sorts of healthy conversations there, and if you're, oh yeah, if you're getting salty about something in particular, or need help, or if you're looking to hire or get hired, we can get channels for those there. Links down here at the bottom if you want to get into forward. GoWest CFP is open, so Mariah's speaking today, and she's a co-founder of that. We also have the other co-founder of GoWest. It's gonna be here again.
Pending approval from the people in the building, yes.
Tentatively gonna be at the Weave offices again. So CFP is out there, please submit and come speak there. It's a fantastic experience and really,
Yeah, AJ, the CFP's open.
Okay, I'll do it. What should I do now?
You literally said you had a great idea for a talk at the last GoWest.
Yeah,
And you did not remember what it was. Okay.
If you want to speak here, not at GoWest, there's a separate CFP link back here for GoWest. If you want to speak here, it's been merged with the WomenWhoGo Utah, so the link on paper call is still WomenWhoGo, but it's all one thing now. Please submit there. I keep saying I really will take all legitimate talk suggestions. You don't have to have the full hour or 45 minutes or whatever you want. If you have a 15-minute thing and want to just come up here for 5 or 10 minutes before somebody else and you have a cool idea, let's bring it up and submit there. I'll work with anybody that has any neat idea for a talk, even if you think it's something trivial. Often the stuff that you think everybody already knows and is boring is still a really great, if nothing else, like lightning talk before a big one. So go ahead and submit there, or even just post to Slack if you have ideas. That's how we like to source all of our speakers.
You can ping Carson on Slack.
Yeah,
Just say Carson Anderson.
I would like to speak.
He's like, okay, what date? Like,
I'll work with you and we'll go over your talk. Even if you don't have something fully fleshed out, just have an idea and want to speak, like I'm here to help people get up and start doing it. And that's it. So that's all I have. I don't like to cover too much at the start of this. We're gonna turn it over to Ryan and Miriah. I think I got this reversed. It's gonna be Miriah first to talk about generics, and that's it. I'll let you do it. Get out of your way.
I'm here.
Just stop sharing.
Baby steps.
Hand over.
Hi, guys. It's been a while since I spoke at a meetup. Just want to say, if you are not on Forge Slack and would like to join, find me and I'll send you an email. That's the easiest way to get on it at this point in time. So yeah, today we'll be talking about generic. I'm going to start off and then Ryan get in with the heavy stuff. Sorry, Scott just walked in and I know it. That's all that matters. So yeah, I'm gonna just kind of go over a little bit of highlights of generics and what's in 118. About me, I am a data reliability engineer at Weave. No, that's not an official title, but that's what my LinkedIn says. So it's as official as it gets. You can find me anytime you want on Twitch, as long as it's a Friday and in the afternoon, because that's when I'm live. I do software development, mostly Go. I have 2 dogs. I am also available on Twitter at Captain Nobody One. And all of my code that I write is on GitHub at Pete. Couple more announcements. There is a course I'm giving for O'Reilly called Production Go. That is May 10th. We do have to pay for that, but I figured might as well get some free points and say, come do that on May 10th. And also GoWest is on October 22nd. And there's a link right there if you want to go to the website. And everybody should go to GoWest because that's the best conference. So I'm gonna open the speaker. Sorry, I'm opening the speaker notes. Hopefully I don't miss anything. So let's go ahead and get started. So half of this stuff from this talk is because stuff I need to, need hiring. There are 4 positions available right now. One SRE, one software engineer, and then back here. Job title pulled right from the job website. So if you're interested, talk to Carson because we both work at Weed. Okay, so generics. Like I said, half the stuff is for me, stuff I had no idea about before diving into it. And then the other half of the talk is going to be basically the 118 implementation, how to write it. So what are generics? I had no idea there was something called parametric polymorphism until last week, and I Googled it. So like in essence, that's all generics is, parametric polymorphism, or a way to keep type safety without like requiring types to be defined in every second. It's like a lot of languages have it. And ideally, in my opinion, the italics are quotes. My opinion only. You can get a lot out of generics if you get a lot of the heavy lifting done by the compiler. That's how you find it in C++ and Rust. I don't know about Java because I refuse to look into Java's generics. Sorry.
Bless you.
So you can get, anyway, like you can maintain the type safety and the compiler can give you a lot of the benefits of that. And then you can use all your different ways of expressing things without being restricted to one specific type. In Go, originally when Go was released, they chose to leave out generics for one specific reason, and that is they didn't want to trade off certain things. They did not want to make it hard to write. They didn't want their binaries to be slow, and they didn't want the program to run, the execution to be slow. So they're like, we're not going to do that until we don't have to make these trade-offs. I cannot say that they still aren't making those trade-offs, but at this point, what they've simplified their polymorphism down to minimizes those trade-offs in a lot of ways with the appropriate use cases, even though we don't know what those are because the Go team never told us what they were. I mean, it's true. They haven't said anything yet. They're kind of what the community to, sorry, we'll get into that later. So they didn't do it at first, but now it's been what, 12, 13, 14 years. They've thought about it for 14 years. They came up with something. And so in 118, it's finally GA. And by that, it means don't use it in production, but you still use it. And what we're going to talk about is we're going to talk a little bit about the syntax and how to use Go generics. We're not going to talk about compile time and binary size. That's an extra slide. And we're going to talk a little bit about some of the basic benchmarking you can get with simple executions and simple functions, like easy practice. The stuff that's not scary. This example was taken right from the GoLang Intro to Generics course. Not course, it's a tutorial. It's got it's a blog post. So essentially, they've got 2 functions. One takes a map of int64s, sums it and returns the total. The other takes a map of float, sums it and returns the total. notice how this part of the function is identical. Because it is duplicated code exactly identical, it is a use case for generics. I don't want to say it's an ideal or a prime or whatever. It just is a use case. It's only 2 functions, so anyway, it is a use case for generics. The way you would write this code generically is like this. You have your function name. See, I had it in my notes what to actually call everything. Right here you have your constraints. We have a constraint on K that it be comparable, that is predefined in Go. That means you can evaluate it with a, what do you call those?
Greater than.
The comparison things, like you could put a not equals to or equals to on it, right? Or you could put a not, it would either be a Boolean field or can be evaluated as a not equals to. For example, you can say 1 is not equal to 2, that's a comparable field. Or a string, right? You can say boo is not equal to far, boo is not equal to bar, that's a comparable field. So anything you can evaluate with a Boolean operator falls under that comparable constraint. And then we have this, which is a union constraint, basically saying V has to be either an int64 or a float64. And then notice after that, right here, everything else is the same, right? We've still got the range, we still return the S, like it is exactly the same. That for loop, identical, we didn't change anything. Go ahead.
So can V be more than 2 different things? So could it also be like an N32?
Yes, you can keep stacking it. They call it a set.
So like, in this case, no, it can't be an N32, but I can add it to the union constraint to add it.
This function won't support in32F, but you can easily do another pipe.
Yes, essentially, if I do another pipe N32, then that would be added to the constraint and it would allow it. There is also, like, we'll get to it, but you can do any, you can do all numeric to the constraint, or you can do all, like things to the constraint, anyway. This might, no, it's not. I don't know why it has, this is saying that this S is of type V, which means it has to be int64 or float64, sorry. I didn't read that right? So we are defining S, which is of type V, which falls under those 2 constraints, right? And then it sums it and returns the value. And that tutorial's right here. We will run this code later. I have some benchmarks on these functions, so I won't run it now. We will run it later, just to evaluate that. So no worries. If you want to follow along, this talk is on my GitHub. So you can pull down the slides, click the link, whatever you want. Sorry, I forgot that part. Okay, you can define custom types just like you've always done with Go by adding constraints. So for example, we have this type vector, which has the constraint T any. Any is basically your empty interface constraint. It just now has the keyword any instead of interface curly brace. Thank you, Ryan, for correcting me on that on my Twitch live last Friday, or 2 Fridays ago, or whatever it was. So, and then the type vector is a slice of T, which could be any possible object, right? It's an empty interface. It accepts anything, no restrictions there.
Any alias for interface is what they.
Any is an alias for interface that comes right, it's built right into the Go standard library now. So we have this function last that operates on our type, right? And basically what it does is it returns the last value of that vector with an error if it's empty. And I have a nice little function here that clearly I was not as prepared for. What example is this? I'm gonna make it big in just a second. Give me. So this, right? Notice we have the exact same function we had right here, right? This was supposed to be deleted. We don't need an ordered constraint there. Sorry. I thought okay, so as you see right here, this main function, can you see that? You want me to make it bigger? I'd be happy to make it bigger. Give me.
A little bit bigger, probably, yeah.
Okay.
There you go.
So this main function right here, calls that last function on the vector type. So we have, this vector, which is basically a slice of ints. Right here, we say this has to be of type int. It can be inferred, right? We could do this, not that, oops. Because we're declaring, anyway, we'll get to that in a minute. This is also valid. But basically we're saying, okay, the gen int is a slice of int, right? That's what we're saying right here. That constraint went from int, we are fulfilling the constraint of int with int right here. Define that. We call last, and then we're going to print that out here. And then notice, then down here, we're doing the same thing, making a vector type, which is a slice. We're saying it's a slice of strings, and then we're going to print that last thing there. So,
Can you make that a little bit bigger, or could we maybe turn these front lights off?
the lights, yeah, here. Oh, go off light. How's that?
Old man eyes, there we
There we
go.
go.
We see that now.
Okay. It was probably better on the video call than here. So anyway, yeah, and then we'll just print out that value of the string, right? And all we want is the last value in the string. So for this case, we should get a -1. It should also print negative number. And then here, we should get the world, and we should not get any errors. So if I just, escape. Let me do my thing. Oh. Escape. Why, I can't press the colon. Colon. Can't press colon, you can't do anything. Wait, can I do? I can record. My colon key broke, guys.
Bim,
Yeah, how am I supposed to, since I'm in Vim, what else would I be using?
make sure you escape a bunch of times, is what I would do.
Just
Keep Shift ZZ, I think.
Oh, really? See escape. Just keep hitting Control C until maybe.
You get it harder every time.
Yeah, and every time, yeah, just.
Literally, at a certain point, I just do this, and I'm like, oh, look, it's gone. Project, all right. Example, types, seriously. Then you do this, then you do that. Go run. Right, so it prints out our negative number 1, which is what we're expecting, and then the world. So it's pretty simple, and we use that same code, right? Maybe this will not break this time, right? And we're able to use the same function both times. Easy peasy, like it's not hard to use it with types. You can also, oh yeah, and this is what I was gonna bring up. Before we were defining it, right, where we defined what type we wanted to use in the vector, right, with the int and string. You can also define it to where the type is inferred. So right here, we're defining the same thing. But this first vector is of type int, right? It's still a slice of int as before, but instead of writing int, the compiler is inferring the type.
Does that work even if you didn't have the var declaration, so you'd say colon equal?
Yes, the colon equals would work as well.
Okay.
It used to say colon equals, but I probably copied it from somewhere else, and anyway.
Cause yeah, well, if you did colon equal, is that?
So I pulled all of these examples from Bill Kennedy's Ultimate book, which is the companion book to his course, and it's dot equals in there. They're not direct copies, they're slight changes for copyright issues. But I found like some spelling error, like some errors in his code, and I messaged him to correct them, so that should excuse me stealing his examples. You know, if I can help him make the book better. Okay. You can also use, just like you can use any generic type, you can use them on structs or on interfaces or basically anything that exists in Go, you can define a constraint on. This is a node type. Again, constraint any, so we can use any type in there. We have this data of type T. So the data in our node struct can have any type in there. And then we have previous and next. The example in the book, which I don't know, we're not gonna run through now. But I've seen this example used several times with generics in this setup. You can then use this struct and a set of companion functions and an interface to write a linked list. So basically it allows you to do algorithms in Go that were previously very hard to do well or efficiently.
But you have to rewrite the code for every type, right?
Exactly. So you would be able to do a link. This previous and next are used to create a linked list. But anyway, I thought it was a great use case of the struct, right? And the fact that you're still able to use a node, which means previous would still have the data type with the next and previous inside of it. Kind of cool. And then you can use it on behavior, right? So that's like what I was saying. And this isn't new to Go, but you can use constraints to implement methods generically onto interfaces. So an example of that, right? We have this interface right here that has a type string. It's a stringer interface. And we're using it on a type. Notice how in this one, because we have a concrete type of user, we can do that here. But here we can use it with an interface that has this method implemented on it, and then it becomes polymorphic. So again, but that's not new to Go. We've always been able to implement interfaces that way. And what you can then do is you can put constraints on that string function. And basically or on the stringer, which would restrict the types you can use. So pretty simple, but to be fair, you could not use stringer if this string function was not implemented on that interface type. So it does require you to fulfill the interface just like regular Go. But like I said, this isn't anything new. It's just saying, oh, now you can add strings to the same way you've always been using interfaces in Go. And so there's not really a guide for best practices, but there are some patterns that have started to be forming. For example, you'll notice that here, the constraint is always a single capital letter or some kind of not snake case. I don't know why I put snake case, but like the camel case beginning with a capital letter, if you want to be more specific. It always begins with a capital letter or it's a single capital letter for the constraint. That's not written in any idiom. That's just the practice that started forming. Also the constraints, like if you defined a custom constraint, like any, or you do a custom constraint of numeric, any custom constraints essentially would be lowercase. So any is built into the Go language, comparable built into the Go language, and they mimic the types, right? Like your union on float 64 and int 64, those are both lowercase. Those are both constraints, so the built-in constraints are also lowercase. Again, nobody is going to get mad at you if you don't do that because nobody's using generics, but that's still kind
I'll get mad at you.
Maybe you'll get mad at you. But again, yeah, nobody's using it. So if we just step back a little bit, I just ran a little bit on benchmarks against that float and int function we saw earlier. So now why is my key not working? It's the key that's broken, I'm pretty sure. We all know how Apple keyboards are, right?
Oh, I've never had one. Big boy.
Oh, you don't use Mac? Is that what you're saying? Yeah, somebody's gonna make me freaking open VS Code.
Did you call it out of work?
My colon also always works so far, yeah. Thank goodness.
I don't use my, I use the mechanical.
And the computer one works
I
too.
do a clamshell, so what the heck?
Apple only made terrible computers for 6 consecutive years.
That's true.
My goodness. Can I map the colon somewhere else? Like, looks like I'll be This computer's brand new too. Anyway, I don't use the colon thing, so I wouldn't know. I've typed on this computer for probably a month. On this keyboard, I use my computer all the time, but different keyboard. Same page. Cool. So now that we're not using Vim because we're no longer cool, we'll pull this up. So right here again, we're back to, oh my goodness, gotta make that actually readable. Nobody wants GitLens. Oh, that's not the right one. No, that's not the right thing either. So in example, right here, so we're back to our generic function. No, this one. Are they both open? I don't know how to use VS Code because I don't use it.
You click the little thing, yeah.
So, yeah, we have our function right here, our sum with the ints, sum with the floats, and then the generic function. So I have just little testing here, a bunch of integers, bunch of floats. They were generated by Copilot, so I did not type that. Copilot was really smart. And then I just have some benchmark functions right here, right? So this is going to be the generic ones on integers, generic ones on floats, and then benchmark the integers, benchmark the floats. That should get us, okay, now we're here. So I ran it, and this is what we got. Notice, like, for that simple function that, like, really didn't give us weird knot, we got the benchmark on generics was 0.9 nanoseconds slower than the regular 64. And then the ints was, what, 0.2 slower than with that hard-coded. So, like, that's not a noticeable loss, in my opinion. But that was a very simplistic, like, we're replacing, very simplistic example. So,
Is it consistently slower or is that just in the noise?
I would chalk that up at noise at this case. What
Can
I,
you run it again?
yeah, we can run it right now. I was going to, I'm sorry if my,
Floats is slower than some generics in some cases, it looks like, so I would think that would be noise.
I was going,
I don't think-
I would say it's noise.
Yeah.
Because the compiler should make an exact duplicate copy of the function that is
I mean, yes.
exactly the same performance.
The reason I say, anyway,
Well,
It doesn't.
It doesn't.
It doesn't, no. We can talk about that later.
I was gonna get there.
My talk.
Brian will probably also get
I
there.
will discuss that.
So wait, do I have my terminal here? Why can't I type in this stupid thing? There we go. So I could go test. I have I have a benchmark one that I clearly haven't used for a while.
Roll
There it is. Oh, I'm not in the right thing. CD example and then run it. I'm not talk, just example. So, see, run it again and it'll work eventually. I don't know why that's moving so slow. Anyway, so the one thing I did, there were some use cases pointed out in an article written by some developers at Planet Scale where they had specific use cases where the benchmark time showed a significant decrease for generics. I have that linked in my references at the back. So there are use cases where you will see the execution time decrease. And those are like, don't use generics then. I've highlighted some of them here. You do want to use generics, like if you're going to use the same logic over and over again multiple times, and again, very simplistic, non-complicated logic, like what we were doing there. Where like if you can parameterize function helpers for the callbacks type, the compiler will flatten them for you. But like, don't just start using generics. Like there are still a lot of question marks around them. Like make sure it's your best option. Know how the memory is being allocated, know how the compiler is running it, and like make sure that you're not taking any losses when you do it. I think it's great for like different types, like, so, oh look, I have a Spanish keyboard on. There we go. But yeah, just like, it's still super new, so don't just go dive all your production code into generics for funsies yet. Make sure it's the best case. And then make sure to give feedback to like the Go team and the community because it's still super new for everybody. Cautions, just read the Planet Scale blog post and they'll tell you exactly some of the issues that they ran into, specifically with performance optimizations. Like their highlight, like the TLDR is they have a lot of code that they have done performance optimizations on, and taking that optimized code and inserting generics killed their performance. So if you've already optimized it, generics is probably not your best fit. If you're starting from scratch and you have no optimization work done yet, and generics then fits, then it will probably, you can optimize them probably about the same level. Yeah, see? You can, this is the words from the Planet Scale. You can deduplicate identical methods, just like what we've done, but don't do it if there's a byte sequence constraint, like that had a problem. That said, don't try, not do try.
Wait, what is it?
No, you do want to try it.
That is a do.
Yeah, so you could make a type constraint of array of byte and string, and then it becomes the same thing so that you don't have to cast from or convert.
Yeah, if you,
Super handy.
that's
Super handy.
one thing you don't want to do, right, and we talked about this a little bit with Ryan, if you have to go back and do type conversions after your generics, that kills your memory. Do this when you don't want to have to, like, if you're never going, if you have to convert a type as part of your pipeline, don't use generics. Because the type conversion does the exact opposite of what using generics was trying to do.
So I'm not familiar with a byte seek constraints.
That one of the built-ins or? is
It's
that-
it's not a built-in constraint. It's, they have in the X package, which is their, Golang Tools X, they have a series of additional constraints. That'd be one of them.
Yeah,
Basically saying it's a sequence of bytes. Like, again, this is, I took these right out of the blog post.
So, yeah, there's a constraints package that has like ordered and byte sequence and it should come into the standard
And
library.
these devils dare to do camel case rather than lowercase?
Well, so lowercase is,
Yes.
it's just like a normal type, it's just like a normal interface, so, yeah, but yeah.
Oh, it's an interface.
Yeah, I mean, type constraints are just like interfaces, so you Pascal it to make it public and then you
Okay.
lowercase it to make it private, so it's just the same.
Whatever, yeah.
Yeah.
Don't get ahead of your talk.
I'm sorry, I won't, I'm sorry, I promise I don't talk about that.
And I'm trying to keep it light and happy. Again, if you've already started inlining or optimizing, don't use generics. And then don't pass it, like, if you're already doing functional programming or you have generic functions, like, it's not a time to pass don't pass an interface to your generic functions. It's really not for functional programming at all.
Primitive types.
Oh, and, don't rewrite interface APIs with generics. Keep your APIs working the way they're supposed to work. No magics.
So this sort of shorthand for pick a lane, use interfaces or use generics, don't mix and match them?
Yeah.
That makes sense.
There are some stuff that the Go team wrote in the release notes. It does not accept, so yeah, the compiler does not accept arguments of the types real, imaginary, and complex as constraints. I'll do it. It does not support accessing the struct of a field.
I'll explain that later.
Understand
I'll
that, but
explain
don't
that
get
later,
into
I
it. Anyway, I'm just presenting you with that. And, yeah, anyway. Be careful with unnamed fields and struct types, like, that's not gonna work. Right, anyway, to inherit. Any high-level questions?
Did they explain why we can't have type parameters for methods on structs?
Yeah. I didn't put that in my talk, but they did explain it. There's a good reason for it.
Yeah, I mean,
It's in the release notes as well.
They just rewrite it to be a.
well, they're saying like, think about using functions. Do that instead of doing methods on a struct.
Which is, I mean, they're essentially the same, right? Like, that's the whole thing about the receivers is.
Well, essentially with generic methods, you end up having to do runtime stuff rather than compile time stuff. So they said that they don't want to implement it because it complicates the implementation.
Yeah, I want to keep everything in the
Sure.
compiler.
Well, every time I need to do it, I literally I can always rewrite it to a function and just take the structure.
That's what they say to do.
Anyway,
Yeah, I was always like, it felt so.
It's a performance thing and the compiler thing.
this is all my resources I used for my talk. Feel free to look at them. Go ahead. See if you have a question.
Did you talk about the tilde, the new thing?
I did not talk about that.
Added-
It's in there. There's the only resource I found that actually has an example of that use case was in Bill Kennedy's book.
What is it?
It's the tilde, which is a new operation added to the types. Ryan, do you talk about the tilde at all?
No, I don't. Go ahead.
So basically what it allows you to do is it allows you to essentially reference a subset of, it's not reference a subset of constraints,
So
but
the-
it-
if I understand it right, the tilde basically means like if I say like tilde, like, I guess, now I'm forgetting what it is, but basically like it means it basically broadens the scope of like a certain type, like if you're saying like, hey, like if you had a stringer, for example, you had a stringer and it said, hey, I need to do this. Well, you might have a type that implements stringer, right? And you're gonna call print or string on that. And so basically doing that little squiggly in generics, it basically says, hey, like, allow me to treat this thing as, or allow me to pass this in, like basically like recognize that this custom type that I made that implements string is also part of stringer.
yeah, it essentially,
If I understand right, it's not like stringer, it's not interface driven, it's if you've type aliased to a
exactly,
string or an int16 or whatever.
yeah,
Exactly, yes, thank you.
I didn't add that to this mostly for time, just because I knew there were gonna be two of us and I didn't wanna take the whole time and it gets really complicated. The only, oh look, Ryan wants to join, share his screen. The only example I've seen from that in all my research was in Bill Kennedy's book. I'm happy to add it to I have an example. So you can take a screen.
Yeah, the good example with that is if you have a custom type and then you want to pass it, let's say you want to add up a bunch of numbers, right? And then you want to call your types like print function. If you just passed in the type without that little thing, it basically, when you call the result dot print or string, it wouldn't work. It's I don't know how to.
Yeah, so yeah, I'm,
Like if you want to access the types function, then you can use that little.
I haven't seen any, yeah, but like I said, I haven't seen any published things besides Bill Kennedy's book on it.
I know I saw
Saying
it.
this is when to use it and this is how I've used it, right? Just the release notes that talk about it. You're good to go. I'm just answering questions. Anything else? No? Well, clearly I should have spent more time on that because we had questions. Yeah, you're good. Okay, I'm gonna try to give the time over to Ryan because he knows everything.
Hello. So I'm Ryan. I'm lead backend developer in Lehi. I'll just get into the about me. So I'm a senior at the University of Utah. I'm graduating this semester. I do research for the University of Utah, and I work with compilers. We're specifically working on like formal verification of backends, which is kind of fun. So we have to prove, that one piece of code is equivalent to the code that compilers generate. So, we want our compilers generating correct code. So we have some really cool methods of doing that. Kind of in my free time, I mentor first robotics teams. And I've been a professional developer for about 6 years now. I worked through college and have been just doing Python, Android, Go, Flutter. So I have good kind of experience with different languages, different generic stuff and all that fun stuff. And, I do work on compilers. And so I happen to have kind of an opinion on this sort of stuff. So a good kind of intro on like why use generics, right? I'm not recommending like, this is how you should use generics, right? But maybe why you want to use generics is you want like some data structure that you want to use for any type. Using the any type works really well. You don't really want to repeat the same code for the algorithms that you use to operate on those data structures. One thing, again, I don't really recommend this, but you want to hide the complexity of type assertions. So one thing a lot of languages do with generics is they have some sort of dependency injection. You pass it a generic type, and then it's probably going to go looking for that type in some sort of registry and do type assertions for you and hide that all. And so you don't have to see the ugly type assertion or typecasting that it's going to do under the hood for you. And then the other thing is that you want the compiler to guarantee that your parameters are only a certain set of types. So before, we would use empty interface, we type switch, and then we have a default case for maybe a type we don't like, and we return an error or panic or whatever you want. In this case, we can actually define type constraints, right? That, we were just showing off type constraints in Miriah's talk, but you can use them as parameters, just like you could use an interface. They're types just like anything else. You don't have to put them inside of your square brackets, right? So you can essentially constrain your inputs to a certain set of types, which is really, really helpful in some cases. Some people call it some type, you can kind of make some types with this, but it's not quite. I really want to, Miriah's talk is a lot about, the high level, how does this work? I'm getting into kind of the nitty gritty on how it's actually implemented, right? So there's a bunch of different implementation strategies that you can do when you're trying to implement generics. So boxing or type erasure is kind of what Java is famous for when it does when it did its generic implementation. Essentially what that means is that if you have a generic method, at compile time, it gets wiped over with object, which is the empty interface if you don't do Java. And then when you generate code, is that me?
It's Derek.
It's
someone rude. He's not even here to defend himself. Dang it.
So the music,
So-
we can't even write
Got
it.
this stupid bar, I don't know how to turn down the volume.
So anyway, so essentially it erases it with object, and then at compile time, it looks for all of the instances that you use the generic method, looks at the type, and then it asserts essentially, or it does a typecast and says this is of this type. That's kind of nasty, and it really ends up making really nasty code. So the next thing, it's a big word, monomorphization. If any of you have been in any Hacker News threads recently arguing about generics, all are using this word, and
I knew the word monomorphization.
Monomorphization, yeah. So all of y'all have been using this to argue that Go's implementation is bad or something. Which, I guess I'm here to argue today that that's not really necessarily the case. So C++, Go, and Rust all use monomorphization. Rust is a little bit different from my understanding, though, in that list. I think they fully monomorphize. So essentially what that means is that, Java boxes its types. So it says, for every instance of, you using this generic code, I'm going to type assert and generate some extra code. Rust says, I will generate a separate piece of code for every single generic method that you use. So if you have an int, a float, a bool, you use all these things, then it's going to end up generating code for that. I don't think it has runtime support for that. So it ends up generating a lot of code. And then there's dynamic dispatch, which is kind of like code duplication, but you end up having this lookup tables. So C# is kind of famous for this because they have a JIT, so they do kind of all of their generic stuff at runtime. They kind of say, we're not going to think about it. We'll let you write your generic methods, and then at runtime, the JIT kind of warms up and is able to do somewhat performant generic code. And C++ and Go do this, except they don't. They do it ahead of time, right? So C++ has its vtables, which you use to look up through virtual functions, whereas Go has something similar to vtables, but we'll kind of get into that in just a minute. And then there's one multiple dispatch, which is Julia. That one's really weird, where essentially it's kind of like monomorphization, except the compiler does not or it will generate a default implementation everywhere you use a generic method, but you can override those generic types. So you could say, you know, like I want to take in two animals, and then you could say, I want a dog and a cat to be this special case where I run a certain algorithm faster. Julia is really good for kind of scientific computing. So you could imagine, you know, maybe you want something different for a sparse matrix versus a dense matrix. And so you have a generic matrix class, but then you implement two different algorithms for that. Monomorphization can create exponential increases in compile time. We saw that with Rust. Rust aggressively did some monomorphization, and they had some like really big problems where compile time becomes exponential, and then the binary sizes were huge. But boxing is not great either, right? That's on the other kind of side of things where we're asserting types essentially in casting, and that can be a lot of, it's little to no compiler overhead, but a lot of runtime overhead, right? So, and most languages try to use multiple strategies in order to kind of get that down. So C++ and Go are kind of notable, and they actually kind of have a lot of similarities in how they kind of mix and match your monomorphization and dynamic dispatch in order to get something somewhat performant, right? So just like before I go on, there's like something really silly about these type systems that not too many people realize. So there's this thing called Turing completeness. Some of you have probably heard of this, but like really simplified, I'm not trying to get into this because this is supposed to be a quick talk, but like, can you implement another programming language with your system, right? So something that is Turing complete would be like Go, right? Go is Turing complete. You could implement a programming language in that. You also can like loop forever in that. That's another kind of property that you can see. One thing that's not Turing complete, notice, is Go's generic implementation. But what is Turing complete is C++ templates and Rust generics, TypeScript's generics are almost, and then just kind of some silly ones. Excel, PowerPoint, and Minecraft are all Turing complete. But Rust, so some people have written programming languages using Rust generics, which essentially what that ends up meaning is they encode all of the data that they need inside of Rust's type system, and at compile time, it resolves all the types and it interprets the language. So that's kind of like scary that like a generic implementation can just do that. But it's like an extra thing that ends up being Turing complete. So I kind of like these.
Does that mean that you could create a type that would enter an infinite loop and never compile?
Correct, yes. Rust has those, I believe. Although they may stop you at like a limit. They may like catch your recursion and say like, you can't do that. So
That's terrible.
yeah, it's terrifying, isn't it? C++ templates are like that too, which are just awful. My research is all C++ and I hate it so much. So anyway, it's the templates suck, right? So Go has generics, right? I mean, Go's had generics for a long time, right? And we haven't particularly complained about these, right? We have, our slice of T, our map of K and V, and our chan of T. One thing that you mentioned, Miriah, is the T being used a lot. So in academics, a lot of times you'll see T for generic types or like a type, and K for a key type.
Across all, I've seen it used across all expressions of generics.
Yeah, all programming languages. It's a very academic thing to use. K and V are used a lot. U is used sometimes, V is used sometimes, it's kind of whatever you want. But, we've had some generics for a long time and the compiler's kind of taking care of this. Just doing monomorphization essentially in order to like generate the code that you need for this sort of stuff. But what we're really interested today is Go's type parameters, right? We don't really particularly care that we've had generic implementations for a long time. Now our methods can make use of these type constraints and these type parameters. So I want to go over like a couple of things. So like, yeah, it's definitely not Turing complete, but so here's where we're going to start getting into like fun territory. So if the compiler can do this code duplication, it's going to, right? So if it can do like a min function is something that's really easy to duplicate code for. Where you have an int, you have a float, it understands that, it can say, yes, we can just duplicate the code and generate two different mins for a float and for an int, and the compiler is okay with that. It does not care. If the compiler does not if it can't do that, then it's going to attempt to use, some form of dynamic dispatch. And then one thing that I kind of want to say that's not particularly special about Go is that it uses what are called reified type constraints, which I'll get into in a second. And type inference, this is where I argue that Go is probably, don't like Go's generics, but I think that type inference is a really, really good argument for why Go's generics are different, and they're not just gonna completely ruin the language. So I think it makes things a little bit better. So let's talk about monomorphization. So we have this num, which is a type constraint of either an int or a float 64. We have this max function that takes in a num, and then if a is greater than b, we return a and we return b. So I ran this through what's called Godbolt, which is like a compiler explorer. This ends up generating two methods. One uses instructions for ints, and one uses instructions for floats. There is no runtime cost for this. This is entirely compile time cost. This code right here is completely and 100% duplicated. The benchmarks, if you were to write a max, would be exactly the same. If you had an int, if you made max int and max float, it would be exactly the same. And that's kind of what we saw with Miriah's benchmarks, right? This sort of stuff the compiler is really good at looking at. It can see into the code and go, yes, I can just generate another function. That's really performant, obviously, but at the same time, that can create a lot of bloat depending on how many different types you're using, right? The bigger your constraint is, the more you use it, then the more code it's going to generate. And in fact, at some point, if you use too many constraints, I can't tell you this because I didn't try it, but my guess is Go would stop doing this monomorphization for you. It would notice that you have 64 different number types and be like, I'm not going to generate you a function for every single number type.
Does it generate the ones that you actually use?
Huh?
So like you
It
have.
only generates the ones that you actually use. That's
So
correct.
a library might have a whole bunch of them, but if you only use one, then you're not.
Correct. Yes, the Go compiler is pretty smart about that. And so when it decides that it's going to do this monomorphization, it does have some heuristics that it looks at in order to decide whether or not it's possible to do that. I don't know entirely the heuristics because essentially, from my understanding, a lot of these generic heuristics are the same as inlining heuristics. And inlining heuristics for Go, I do talk a lot about compiler optimization in GCC and Clang and that kind of stuff. And we try to, we try to verify that those optimizations are correct. Go's optimizers pretty bad compared to C. Obviously, it's had 40 years, but the inliner is not particularly great. So I wouldn't bet my life on doing it with loops, for example, or deeply nested loops. I hope it would go. So I don't know what its heuristics are exactly, but in this case it does end up generating two functions, but only it doesn't generate one for in 64. Right, or float 32, yeah.
Does doing monomorphization tend to, you said that the inlining is kind of with Go, but in general, it's good to do that because normally compilers would want to inline, right?
Typically most compilers have some sort of inlining heuristic, right? So inlining can actually, it can slow code down at some point. So, there's no inline thing that you can put in Go. In GCC, there's also no inline attributes that you can add. Sometimes the cost of a function call, if you're calling it a lot, right, over and over and over again, the inliner will say, okay, maybe in this deeply nested loop, we can inline this really simple function call. But, it kind of just depends, because if we were to inline everything, you end up with bloat and your binaries can't fit in memory and you're cache missing when you're trying to jump out to things. So binary sizes will actually slow your code down if you have too big of a binary. So inlining is kind of iffy. I don't think that the Go developers are really bad with it, but yeah, it's the same as monomorphization. You don't want to rely on it too heavily, or else you'll get really poor performance of your app, right? So the next thing, so we were talking about the less than sign, right? So you can do like constraints.ordered. If you have a bunch of int types in your constraint, you can use like a less than sign, right? Like this is valid over here. This is valid code, even though it's not like we have any methods like operator overriding, like C++ would have, right? So the compiler understands that for all types of A and B, the greater than operator is valid, right? So Miriah mentioned at the end of her presentation, but if we have two fields or if we have two structs that have the same fields, or even this struct that just has this field, and we create a type constraint, can we access my field from that type constraint? The answer is no. Like the Go developers, like they thought about it, but someone brought it up and they were like, yeah, we wanted to kind of push this off because, in Go, it's kind of a fun fact. So base fields here, you can actually use just base as a base fields. And that's because it has the same field name, the same field type, and I think the tags have to be the same too, but there's a bunch of constraints. So, but when you try to use just base as a field, base fields, like in its constraint, it fails and it won't work. So, this code has a lot wrong with it, and if I run it, you'll see like all the things that are wrong with it. Yeah. Oh, wait, oh wow, I missed some syntax. That's cool. I thought that I must have messed something up earlier, but yeah. So the question is still can we do this yet? And the Go authors have not answered. My opinion is that this is kind of terrible because we've always said that interfaces can't have fields, and this is essentially saying, yeah, what if interfaces could have fields though? And it's like, I don't know, but they're discussing it. But for now, it really only works for number operators, less than or equal to, comparable things. So that's kind of how it works. And, monomorphization could solve this problem here, but it looks like the Go developers have decided that that's not what they're going to do, right? So this gets onto dynamic dispatch stuff, which is what most of the people are complaining about. With Go generics, right? So Go's implementation of generics, essentially the way that they do it is they keep track of a dictionary of every possible type that you have, used a generic method with. And then when you go to call it, it does a lookup and says, what type are you using this with? And it grabs some type information and so that it can call a method, right? So that's an extra pointer reference. It does a hash map lookup to get the type information so that it can then make a method call, right? So that's an extra pointer dereference. Some people are complaining about this. C++ does this with vtables. I'm not too particularly mad about this, right? This isn't something that like people who are really weird about performance are mad about this, but C++ does it too, and people have been arguing about vtables for longer than I've been alive. So anyways, but so the big problem is actually when you pass in like an IO writer to this function right here, an IO writer. And the reason is because the compiler can't figure out what's underneath your IO writer. And so in order to get where the method is in memory, it has to do a type lookup. So it says, what is it, or it has to essentially cast underneath. It says, what is under the hood? Is it a response writer? Is it a whatever? You have to, under the hood, know exactly what type it is. And so this ends up with a function call, which just kills your performance. Function calls are the last thing that you want to do in performance every time you want, do a type lookup and you want to call a method. It's just awful. So the Planet Scale guys argue that more aggressive compiler optimization would fix this issue. I argue that yeah, maybe, but this sort of compiler optimization is really hard. The Go team doesn't seem to like compiler optimization that much. They don't particularly want to do what's it called super crazy optimizations C and C++ have done, and there's actually things in the language spec that don't allow them to do that. So yeah, I don't expect that this will get better much sooner. And so really, I guess my question is for most people is why are you writing this? Like, there's no reason to write that. Like, just pass in a function with an IO writer. So, generics can be used in like really dumb ways, but channels can be too. Just about anything in Go can be used in really dumb ways. And so I just don't see really the argument to like why this is this isn't real code that a real human writes who understands anything about Go or a type system at all, right? This is like to show off, like, haha, if you write bad code, it generates bad assembly. It's garbage in, garbage out type of deal. So the other thing that I wanted to talk about is reification. So reification is kind of important in like Java. Java doesn't have what are called reified types, and the idea behind reified types is, if you look at this, I wrote it in Kotlin because I hate Java, and Kotlin is JVM language. It's better. So and you can write just these naked functions. But so you have some type T. If you do param is T, this is going to fail, and that's because of the whole type erasure and boxing thing. Is that Java is going to erase the type T, so it doesn't know it doesn't particularly know what type T is. The compiler doesn't know, so it says sorry, like the type is erased, and I spelled erased wrong. Go on the other hand, essentially acts as if this type is a parameter. So you can use it like it's a parameter. And I wrote a type switch using this type constraint. It can be a string or an int. I casted param, which is an interface to a T, and I can check to see if it is a foo and return foo. This stuff compiles and this runs. So, this is kind of more interesting. Like reified types, have a performance hit because it's an extra lookup, but again, it's really not that bad compared to passing in an actual interface. But it can create some really interesting code and create some really cool stuff here if you kind of use it right. Yeah, so reification is cool. Go does reification, so there are, I think, some really good things that we'll be able to do with reification. So this is, okay, so type inference, us developers don't really want to say the type of things, right? We use colon equals a lot in Go because we say, please infer my type. Like, I don't really want to choose what type it is, like just colon equals, like figure it out compiler, right? So the same goes with generics, right? You want to create some min method that takes in two numbers, returns the minimum of it. I don't want to have to put float in every time I call min. I want it to figure out that I'm passing in two floats. So that's good. But this is, I think, where I argue that Go, this is why, type inference is why Go will not become like Java, or will not become C#, or will not become C++, where all these languages are just have some super nasty types that you can create and super nasty things you can do with generics. And the reason is because of type inference. And so, so this code looks kind of complicated, right? So you have some struct, it has a method m and it returns a byte of 0. You have this interface which takes in like anything, right? And it has a method m of t, so you can see we're setting up probably this is going to be a byte, so that m returns a byte, right? And then in here we're getting more complicated. We're saying, there's some type x which takes, which is constrained by an I of t, where t is any, and then x you call m. And if you attempt to call f on s, like maybe you would want your type or your compiler to figure that type out for you, but Go's not going to do it. So Go says, you just created a monstrosity that I don't really want to deal with, and so I'm not going to tell me what types you want that with. So, in reality, like the really nasty generic code comes from, like if you've ever done C++ template programming, you put in some type and you just see this massive template error and you're like, what does that even mean? Like I can't tell you. And the sort of type system craziness that you can pull in C++ doesn't exist here, because like who's going to write out those types? Like no one actually wants to write those types out. It's like it's really hard to do that. There's building anything sufficiently complex like C++'s type system. It's just not going to happen, I don't think. So I don't see this as a bad feature. I think that In general, the Go team has done a pretty good job of, getting to the heart of what people need generic programming for, and what people don't need generic programming for, and optimizing for the useful case, and then also making it so that our compile times are exponential, right? There was an increase in compile times. I'm sure everybody's seen that GitHub issue that got opened, 17 to 20% compile time increase. Yeah, but if it were Rust, then we'd see like 150%. I'm not mad about, that small of an increase. So anyways, the type inference, Go just doesn't really mess around and makes it stupid simple and really only goes like one level deep. The other thing is if you attempt to do recursive types, it will just terminate and tell you that it won't compile. So, you could pass in from a T, you could pass in like an I of T, and it can create this like recursive type, and it won't compile. So that's like another good thing, Rust or C++ might attempt to they'll either recursion depth or they'll attempt to make some runtime shim so that you can do that. But Go just doesn't allow it. And then the last thing, this is essentially the end of the talk. So what's up with the braces, right? Like everyone's using the braces now, or Go's using the braces. Everyone sees generics with the angle brackets, right? So this is just I do a lot of work with compilers, and so I've written a compiler before, I'm lazy, they're lazy. The reason why we don't have these angle brackets is because of the fact that we can do multiple assignment. In Go, this is a really nice swapping, a way of doing swapping. You can say the array of 0 and the array of 1 is equal to the array of 1 and the array of 0, and it swaps that for you. The problem here is that when you get some sort of expression like this, A and B is equal to W is less than X and Y is less than Z in parentheses. The question is, well, is this W with parameters X and Y, type parameters X and Y of Z, or W is less than X and Y is greater than Z? And the answer is we don't know unless we know the type information, and the Go team does not want to figure that out. So if you do it this way, the ambiguity goes away because you either you have this comma boundary, this is a valid indexing expression, but then you get an identifier after, and it's immediately clear that what you just started parsing is entirely wrong. So that's just kind of a silly thing. Why I know it sucks that we don't have the angle brackets, but it makes a lot of sense when it comes to not making the compiler super complex. So anyway, my takeaways are: be careful when you use generics, but don't be too cautious, I think is kind of it. It's just you don't have to say no generics in the code base, but you also don't have to say use generics everywhere I possibly can. Because both of those, okay, use channels where everywhere. Don't use lists, use channels. No one's gonna do that. That just doesn't seem like, something that you should do. So yeah, I think that's kind of my takeaways. But anyway, hopefully that was informative. So any questions? Yeah.
So one of the things I was most excited about with generics was not writing them, but using a built-in collections library. Is there a winner out there? Are there there's gotta be 4 or 5 that are vying for attention now.
So there was one that was Low, if you've ever used JavaScript, Low Dash. It was very similar to Low, and I think they called it Low or something. And the big thing, the collections libraries in Go kind of get messy because your Lambda syntax, your anonymous function syntax kind of looks iffy. But yeah, I mean, it's not just an arrow function like most languages, or it's not very pretty looking, but there are a lot, but I think it was called Low. I can't remember the GitHub name because I haven't started using it. I have some generic code in production right now, but I don't have generic collections libraries used in production.
Exactly called Low.
Yeah, it's called Low, yeah.
/Low.
Yeah.
Cool, no, thank you, I'm excited.
Yeah, Low looked good. Any other questions about implementation details? Yeah, go ahead.
So earlier,
Yeah.
we were talking about the performance difference in the code.
Yes.
And specifically the example of the int and the float. using a generic function.
Yeah.
And whether or not the performance difference was in the noise.
Uh-huh.
So if it's monomorphization,
Yeah.
forgive me for not being able to say that.
Fine, don't worry about it.
Isn't that a fun word?
It is a fun word.
I don't think the Go team would use that word. Do they use that word?
They do.
Really?
Yeah, monomorphization.
It's a.
You have to read the proposals, though. You can't,
They
this
would
is.
use it in the blog post, but
There-
they'll use it in the design doc.
No, yeah, if you read the design docs and you read through all the code and then,
So, but in this case,
uh-huh.
you get exactly identical performance because it is exactly a copy of the code.
No, it's literally exactly the same, yeah.
Yeah, okay,
Yeah.
that's what I was expecting.
As long as you're doing no dynamic dispatch.
If you, as soon as you have an interface, gone.
Okay, but if you use an interface, then it's doing the dynamic dispatch instead, and that's
Yeah.
where you get the double pointer performance hit.
Well, so, yeah, so it could be a double pointer or a pointer to a pointer lookup to a method call. So those are your two options. The double pointer lookup isn't that bad. I don't think that it's that bad. C++ does this. People complain about it. I don't think it's that big of a deal. With the method call though, yeah, method calls are awful, like for performance, like jumping to somewhere else randomly is awful. So the dynamic dispatch, it depends on whether it knows if it's a concrete type, if it's a strings.builder, right? That's like a pointer to a strings.builder. That's a concrete type that we know is a writer. We don't have to do a method call for that, right? But if we have an IO writer, we just pass in like, we say like var IO, IO writer is equal to strings buffer, right? Essentially like you create a generic, or like just an interface type, and you cast your buffer, or not cast, you use your buffer as an interface type over here and you declare it as such. Then you pass that in. All of a sudden, it has no idea what's happened here, right? Because your IO writer could be anything. It needs to know the underlying type in order to be able to make a method call. And so it has to call a method, go looking through the runtime information to be able to do that. So you have to be careful if you pass in, if you have an interface here, right? If this is like an IO writer, as long as T is not an actual IO writer, you aren't passing in something that's been converted to an IO writer, as long as it's a concrete type such as strings.buffer, you are completely safe. You get an extra tiny performance hit, tiny.
So I think if we just follow the axiom of interfaces over generics,
Yeah.
in places where interfaces would work, it would be dumb to use a generic.
Yes.
No, see, that's what I argue is like the stuff that they like Planet Scale showed off, like no human would think that this is a good idea. This is like some fuzzer running, like trying to see what happens.
More. Get you out of the field more, see some shit.
This is like, I mean, I was messing around the other day where like, you can technically just be like, oh yeah, this is really funny. What if, instead of passing in a num here, just put tnum and t, and it's like, okay, like what did I gain here? Or like you can make these generic parameters. You could be like t, string, a, t. It's like, what else could it be? It's a string. Like you can do this sort of stuff, but yeah, in general, I do agree with you that like using just an interface would be good because it doesn't have to do that assertion under the hood. The compiler is good enough that it can just it still is an extra table lookup because it's an interface is my understanding, no matter what, even if it's generic or not. But, in the end, generics, I mean, don't be stupid with generics. Don't write code that doesn't make sense. We have other tools, right? So.
This is
my
why I
opinion.
wanted Ryan to speak with me. I wouldn't have gotten that, dude.
So,
It still boils down to what we were saying in Slack. The only real valid use case, other than edge cases that you'll come across and you'll know when you see them, know if you think you have them, you don't have them, is generics for data structures.
Yeah.
That's it.
Yeah, I mean, as soon as you start adding constraints, like, yes, they have allowed interfaces and stuff, but as soon as you start adding that stuff, it's like, why are you doing that? Like, what good does it do for you? It probably doesn't, right? The other thing, just I wanted to quickly mention, we were talking about the tilde thing, right? The tilde operator. So the performance is the same for the tilde operator as well. So this example, you used to have a tilde on the float, and it had like a type def of like duration a type to duration to float or something. But anyway, yeah, The performance is the same for the tildes, so.
That's what it did. The tilde lets you, so if you have a type, right, that basically aliases another type or wraps another type under the hood, the tilde allows you to basically bypass that extra type instantiation to the under the hood. I knew I read
I was
about
gonna
it.
say, yeah, be careful. Type aliasing, it doesn't care. So if you were to type alias and int, so type A equals int.
Sorry, not that, but like.
But if you were to
the
say like type B
duration-
int.
Sorry, the duration was the key example, right? Because type duration is if you were to define, look at how that's defined in the time package. It is time, type duration, float 64. So it
Correct.
is a float 64.
Correct.
That is a go type of type duration, but the tilde says, just treat this as a float 64.
That's exactly it.
That's what I was trying to say.
And there's
And that's
no,
what I forgot. I told you I read about it.
and there's no runtime hit for that. It's the same. So there's no runtime hit. The compiler
I
understands.
mean, I would.
Compiler expansion,
Huh?
it's a compiler
Yeah,
expansion.
the compiler looks down to its base type. It goes all the way down the chain.
We do that with, so like num is an interface of two types,
Yeah.
two possible types, I should say.
Yeah.
Could I have one of like float and one of like float 64, float 32, float 128, all of
Yeah.
Oh,
and then one of int, and then like combine them with tildes and be like, yeah, it's all the things.
Right, so when it goes to look up for your num, then it's going, and you have like a duration, then it's going to go down to the base type of the duration, which is a float 64, and it says, it satisfies it.
It'll only do that with the tilde?
It only does it with the tilde, so the duration wouldn't work here.
So the same thing with like a uint8 and a car and.
Exactly.
Exactly, that's it, right? You say, I want it to be the same, put a tilde in front of it. I want anything that.
You can, if you can boil this down to something that's a float 64,
Correct.
whatever I give you,
Yeah,
okay.
exactly, and there's no runtime hit for that, so it compiles to the same stuff, so. Yeah. So, Go generics aren't that bad, I promise, so.
Can we apocryphally call it the unboxing operator?
I mean, boxing.
Certain color websites, you can call it.
So anyway.
I might know some people that would slap you, but.
Wait, I apologize.
No,